Chapter 1.2.8 Garbage Collection. Garbage collection in Kubernetes refers to the processes used to clean up cluster resources, such as terminated pods, completed jobs, objects without owner references, unused containers and container images, dynamically provisioned persistent volumes with a storage class reclaim policy of delete, stale or expired certificate signing requests, CSRs, and nodes deleted in specific scenarios. This cleanup is important for maintaining system efficiency and preventing resource wastage. Garbage collection can be managed in various environments, including cloud-based clusters with a cloud controller manager or on-premises clusters with an add-on similar to a cloud controller manager. Node lease objects are also subject to cleanup as part of garbage collection efforts. Owners and dependents. Owner references in Kubernetes are used to establish dependencies between objects, allowing the control plane to manage related resources before deleting an object. This mechanism is different from labels and selectors, which are also used to organize resources. Owner references help different parts of Kubernetes avoid interfering with objects they don't control. Cross-namespace owner references are not allowed, meaning that namespace dependents can only have cluster-scoped or namespaced owners. A namespaced owner must exist in the same namespace as the dependent, or else the owner reference is considered absent. Cluster-scoped dependents can only have cluster-scoped owners. In version 1.20+, if a cluster scope dependent references a namespaced kind as an owner, it is considered unresolvable and cannot be garbage collected. If an invalid owner reference is detected, a warning event is reported. You can check for this type of event by running a specific kubectl command. Cascading deletion. Kubernetes has a feature that checks for and deletes objects that no longer have owner references, like pods left behind when a replica set is deleted. When an object is deleted, Kubernetes can automatically delete its dependents in a process called cascading deletion, which can be done in two ways: foreground and background. Foreground cascading deletion involves the owner object entering a deletion in progress state, with its deletion timestamp set and finalizers field updated. Dependent objects are then deleted before the owner object is finally removed. Background cascading deletion, on the other hand, immediately deletes the owner object and relies on a garbage collector to clean up the dependents in the background. If dependent objects are left behind after the owner is deleted, they are referred to as orphan objects by Kubernetes. By default, Kubernetes deletes these dependent objects, but there are ways to override this behavior if needed. Both foreground and background cascading deletion processes can be managed using finalizers in Kubernetes. Garbage collection of unused containers and images. The kubelet performs garbage collection on unused images every 2 minutes and on unused containers every minute. It is recommended to avoid using external garbage collection tools, as they may interfere with kubelet behavior. To configure options for unused container and image garbage collection, the kubelet can be tuned using a configuration file and changing parameters related to garbage collection using the kubelet configuration resource type. Kubernetes manages the lifecycle of all images through its image manager, which works in conjunction with Cadvisor. The kubelet considers disk usage limits such as high threshold % and low threshold % when making garbage collection decisions. Garbage collection for unused container images is a beta feature in Kubernetes v1.30, allowing users to specify the maximum time a local image can be unused for, regardless of disk usage. Container garbage collection is also managed by the kubelet, with variables such as minage, max per pod container, and max containers that can be defined. The Kubelet garbage collects unidentified and deleted containers, typically starting with the oldest first. In situations where there is a conflict between max per pod container and max containers, the Kubelet adjusts max per pod container to address the conflict. It is important to note that the Kubelet only garbage collects containers it manages. Configuring garbage collection. To optimize garbage collection of resources, adjust settings tailored to the controllers overseeing them. This can be done by configuring options for specific controllers. Learn how to fine-tune garbage collection by reading about configuring cascading deletion of Kubernetes objects and cleaning up finished jobs.